Absolute value equation. So recall, the absolute value of a number is the distance away it is from zero, expressed as a positive number. So number one says, which values of x could satisfy these absolute value equalities? Okay. So A, we have the absolute value of x equals 8. So what it's really asking is it's asking what numbers are 8 away from 0 on a number line? Well, the answers to that would be 8. Whoops. Would be 8. X could be 8. Or it could also be negative 8. The absolute value of 8 equals 8. And the absolute value of negative 8 also equal 8. Those are both answers to that equation there, that equality right there. Similar to B, the absolute value of 5 is 5, but also the absolute value of negative 5 is 5. If we were to substitute those into the equation, they both ring true, right? Absolute value of 5 is 5, and the absolute value of negative 5 is 5. Now, C says the absolute value of x equals negative 7. So what could be a solution to that? What about positive 7? Well, the absolute value, don't write this, I'm going to write this in blue. Well, the absolute value of positive 7 is positive 7. It's not negative 7. And the absolute value of negative 7 is positive 7. So neither of those are answers. This has no solution. This has no solution. The absolute value of a number is always positive. So that one doesn't have a solution. D, it says the absolute value of what number equals 0? The answer to that is just 0. There is no positive and negative 0. 0 is like neutral. So there's only one answer to this, just 0. So the big takeaway is down here. Let me maybe pull up my highlighter. If we have an absolute value equation that is positive number equals a positive number, then there's two solutions. If we have an absolute value equation that is a negative number, there will be no solutions. That's indicated here, right? Negative number, no solution. Positive number, we got those two solutions. And then lastly, if we have it equals 0, then there's just one solution. Just one answer there. Okay, so keep that in mind as we're doing these problems. Okay, so it'll start to make a little bit more sense as we start solving. Okay, so I'm going to do quite a handful of these. So just follow along. I'm going to kind of pick and choose which ones I do, though. Okay, A says the absolute value of 4x equals 12. So in order for it to equal 12, what's in here has to either be a positive 12, because the absolute value of 12 equals 12, or a negative 12, because the absolute value of negative 12 equals 12. So what I'm saying is this 4x needs to either equal positive 12, or this 4x needs to equal negative 12. Because again, the absolute value of positive 12 is 12, and the absolute value of negative 12 is 12. So either 4x needs to either equal positive 12 or negative 12. So then we solve this. Divide by 4. X is 3 as an answer. Divide by 4. And so is negative 3. Two answers. Now let's look at B. The absolute value of 3x needs to equal negative 6. So you may be thinking, oh, maybe 3x needs to equal 6. But the absolute value of 6 doesn't equal negative 6. It equals positive 6, so I can't set that equation up. You might think, oh, negative 6 maybe. Well, the absolute value of negative 6 is also positive 6. So you can't set up 3x equals negative 6. That doesn't work either. This is one of those no solution examples because it equals a negative number, right? Negative number is no solutions. So I need to erase some of this. It's getting a little too muddy. So since this equaled a negative number, there's going to be no solution on that. Okay. Let me do, distracting. Let me do C. So this is a positive number, that's 7. So I know there's going to be two solutions to this. So the absolute value of x minus 5 equals 7. So that x minus 5 needs to either either equal a positive 7 or a negative 7. Because inside that bar, this needs to be either positive 7 or negative 7 for it to equal 7, for the absolute value to be 7. And then you just solve these both. Two solutions on that. D, if you look at D, look, negative again. You can't take the absolute value of a number and get a negative answer. Remember, when you take the absolute value of any number, it turns positive. This is also no solution. And that is because of, let me circle these in red, the negative. E, we don't have that problem. Absolute value of 2x minus 5 equals 3. So this 2x minus 5 needs to either equal positive 3 or negative 3. Now I'm going to show a little less work on this. So, we've been solving a lot of equations this year. So add 5 to both sides. That'd be 8. Divide by 2. X is 4. Add 5 to both sides. We have 2. Divide by 2, 1. Those are the solutions to that one. Now, F is a little bit interesting because it equals 0. So if we think back to our rules up here, there's really only going to be one solution of this. And the reason being is because if I try to break this up and say 3x plus 6 needs to equal 0. I'm not going to say 3x plus 6 equals negative. That doesn't make any sense. You can't have as negative 0. So really 3x plus 6 equals 0 is the only equation I need. I just need what's inside there to equal 0. The absolute value of 0 is 0. So subtract 6 from both sides. Divide by 3. We just get one answer there, just negative 2. All right, I'm going to show more. I'm going to do I. Let me do G also. Let me try to do some more just because it's kind of confusing. Okay, so what's in there, the negative 2x plus 1 needs to either equal 13 or the negative 2x plus 1 needs to equal negative 13 because the absolute value of 13 and negative 13 also equals 13. Subtract 1 on both sides. I get 12. Divide by negative 2. I get negative 6. Subtract 1 on both sides, I get negative 14. Divide by negative 2, I get positive 7. So there's a little quick example for you. Maybe I shouldn't have done that one because I want to make sure you're getting practice. I feel like I'm doing a lot of them. But yeah, you could have tried that one on your own and checked because this one's going to be no solution. So I guess I've kind of been doing a lot. I'm going to try to do a little less now. Okay, I'm going to do I, but you can do J. Now this one's a little bit unique. And the reason being is because like we have this plus 4 that's outside the absolute value bars. So before we can kind of split this up, we need to get rid of that. So I'm going to subtract 4. And then we have 2. So I have absolute value of 1/4 x minus 5. And now we can break it up. So I need that 1/4 x minus 5 to either be positive 2, or I need that 1/4 x minus 5 to be negative 2. So I solve both of those, add 5 to both sides, 7. Divide by 1/4, or to get rid of 1/4, you can multiply by 4. Either way, x is going to be 28. Add 5, that's going to be 3. Again, you can divide by 1/4 or just multiply by 4 to get rid of the 1/4. So that could be 12. So I'll let you do J. So on J, you're going to add the 1, and then you're going to do everything from there on out. Okay. Let me do K. Now, K, again, that 3 is outside the absolute value bars. So my suggestion, and it's multiplied to that absolute value of x plus 4, my suggestion would be to first divide by 3 to make it easier. And now we can break it up from here. So x plus 4, what's in the absolute value bar, needs to either equal 6 or negative 6. So I'm going to have x plus 4 equals 6. X plus 4 equals negative 6. Subtract 4 from both sides, I get 2. Subtract 4 from both sides, I get negative 10. I'll let you do L. Let me do M. So M has a couple parts with it. So it has that plus 1. I kind of want to isolate the absolute value bar. So I'm going to subtract the plus 1 first. So I have 2, x minus 5. Now I'm going to divide by the 2 because the 2 is being multiplied to the x minus 5. So now I have absolute value x minus 5 equals 3. So now I've kind of isolated those absolute value bars. And so now I'll do the break it up thing. So I need that x minus 5 to either equal positive 3 or negative 3. So x minus 5 needs to be positive 3, or x minus 5 needs to equal negative 3. Add 5 to both sides, that'd be 8. Add 5 to both sides on this one, it'd be 2. That's what I got. Let me do one more for you. I'm just going to do O. Just so we don't lose sight of this, because this one's one of the special cases. Subtract 10. That's negative 2. And remember this, let me highlight it, negative. You can't split it up here because the absolute value of a number is always positive. So this one's going to be no solution. All right, I'll let you play with the rest of them. I don't want to do too much for you, so I'll let you play with the rest of them. I'm going to show you one word problem, though. Let me scroll down here. It says, Matt is a fair worker operating a game where he guesses a person's age. So I don't know if you've ever seen that game, like they got somebody and they try to guess your age within a certain proximity. So it says if he guesses within 5 years, he wins the game. So it says a person 57 years of age participates in the game. So basically, like, he's got to guess within 5 years. So he might guess the person. So if the person's 57, in order to win, he needs to guess between like 52 years and 62 years, right? Because those are both 5 away, right? So he's got to be, because he's got to be within 5 years to win the game. So his person's 57, so he's got to guess between 52 if you subtract 5, and then 62 if you add 5. So like understanding what the question's about can definitely help us, especially in the end when we try to make sense of our answer, because we got to make sure our answer makes sense. So like I already know the answer, but the question wants us to create an absolute value equation for it, which might seem a little weird, but anyhow, A says write an absolute value equation that will reveal the highest and lowest guess in order for Matt to win the game. Okay. So I'm going to say his guess is X. So the difference between his guess and the person's age has to be within 5, meaning 5 positive distance and 5 negative distance. Let me say that again. The difference between Matt's guess and the person's age, Matt's guess, which I'm going to call X, and the person's age, which is 57, the difference between those two needs to be within 5, meaning 5 above in a positive direction or 5 below in a negative direction. So I'm going to say it one more time as I write it. The difference between Matt's guess, so difference is subtract the difference, Matt's guess minus 57, the difference between his guess needs to be within 5 of the actual age. So that absolute value, the distance of his guess, needs to be within 5, either 5 positively or 5 negatively. So as I solve this, I'm going to say X minus 57. The difference between his guess needs to either be 5 away for the highest guess, or 5 below for the lowest guess. So I solve each of these equations. 62. Let me just write the plus 57. Sorry for the bad handwriting. And that's going to be 52. Whoops, I want to do that in black. So the highest, 52 years old, and 62 years old, and 52 years old. Those are the highest and the lowest guesses. So setting up the equation can sometimes be kind of confusing, but do your best and always look at your answer. If your answer doesn't make any sense, then go back and try to fix that equation. I'll let you do the rest.